Hello. In this section, we're going to cover special products, so special cases of multiplying. In the prior section, we learned how to multiply binomials. It's double distribution, or you can always use a table, like a multiplication table. So today we're going to cover the last part of multiplication and the very beginning of division. To get us warmed up, I'd like you to try the following cases. Test whether these are true or false statements. Is 3 plus 5 quantity squared the same as just doing 3 squared plus 5 squared? And based on your answer to 1, can you predict what the answer to 2 is going to be? And 2 is actually the lead-in for what we're going to be looking at in today's section. So if you would, pause the video now, come back after maybe a minute. You've had a chance to try the warm-up, and we'll see how you did. So pause the video now. Okay, what you should have discovered is it actually turns out that these are false. You cannot do this. 9 plus 25, 3 squared plus 5 squared is 34. But if you do order of operations correctly, 3 plus 5 is 8, and 8 squared is equal to 64. And 64 does not equal 34, so this is false. You cannot simply just distribute the power into each of those and square both of them and then add. You have to do something else entirely different, which is what we're going to look at today, which means that this is not going to be true. X plus 5 quantity squared does not simply equal x squared plus 25. Rather, to square means to multiply something by itself, so you have to write it as x plus 5 times x plus 5, and then actually multiply the items out. Distribute your x, distribute your 5, and then get your final product. We'll come back to this here in a moment. The actual lesson starts with this one. If I want to do x plus 2 squared, I cannot simply write this as x squared plus 4. It is not true. So how are we going to do it? Instead, we're going to recognize that to square means to multiply something by itself. So it's x plus 2 times x plus 2. Now, in the last section, I showed you can either use a distribution method to do this. This would be double distribution because you're distributing the x through it first. Then you'll come back through and distribute the 2. If you distribute the x first, x times x is x squared. X times 2 makes 2x. If you distribute the 2 then, 2 times x is 2x, and 2 times 2 makes 4. If you combine your like terms, you'll get x squared plus 4x plus 4. And that is the correct answer. If you use a table, it looks like this: x plus 2 times x plus 2, x squared, 2x, 2x, 4. If you add up all the pieces, you will get the same answer. So to square, you have to multiply something by itself. There are no shortcuts. We're going to try it with this one. Actually, I should point out to you that there's a specific pattern that occurs with this. When I'm doing a plus b quantity squared, I am going to get a squared and I am going to get b squared, but I'm going to get twice of a times b in the middle because I get an ab and an ab. If you use the geometric tiles, you'd see it here. You get ab and ab. Most people get the a squared and the b squared, but they forget the ab's in the middle. So for example, if I had x plus 5 quantity squared, I get x squared and I get 25, but I will also get a 10x in the middle. So when I multiply this out, I'm going to get x squared, 5x and 5x makes 10x, and 5 times 5 makes 25 at the end. That middle term is always the double of the other two parts of each individual binomial. Let's try it even if I have a 2x out front. So 2x minus 3 squared is 2x minus 3 times 2x minus 3. You cannot try to take a shortcut and write this as 4x squared minus 9. It is not true. 2x times 2x. So I can use double distribution. Distribute the 2x first. 2 times 2 is 4. X times x is x squared. 2 times negative 3 is negative 6, and then we're counting x's. Negative 3 times 2x is minus 6x. Negative 3 times negative 3 is 9. I get 4x squared minus 12x plus 9 is my final answer. If you use a table, you will get the same answer as long as you use the table correctly. When you fill it all in, you'll notice there it is, 4x squared. Hey, there's the doubling. That's why these pieces are always going to be the same, because I'm squaring something, I'm multiplying by itself. So it's twice of the minus 6x's. So 4x squared minus 12x plus 9. I'm going to give you a chance to try. So use what we just did as a guide and try these two for yourself. Maybe pause the video for a minute, come back after you've had a chance to try. Okay, let's see. When I multiply this out by itself, I get x plus 3 times x plus 3. That's going to give me, when I distribute, x times x is x squared, and then a 3x, and then the 3 distributes. I get another 3x. There's that doubling, plus 9. I'll get x squared plus 6x plus 9. Even if I have a coefficient in front of my variable, I can do it. 6b minus 1 times 6b minus 1. Distribute the 6b first. That'll be 36b squared. Then minus 6b, and then another minus 6b. There's that doubling again, plus 1. Combine all my like terms, and I will get 36b squared minus 12b plus 1. And that's the first of our special cases. We have one more special case multiplication. Let's use the first one as our guide, and I bet you can almost figure out the second one for yourself. So distribute the r through first. We get r squared. Then I get minus 3r. Then distribute the 3. I get plus 3r this time, and 3 times a negative 3 is negative 9. Now notice when you combine your like terms, what happens in the middle? It makes 0 because these are the exact same number but opposite in sign. So my final answer is just r squared minus 9. Why did the middle term cancel out? Because these are the same number opposite in sign. I bet you could use that as your guide to just jump straight to the answer for this one. It will be the first thing squared, the second thing squared with a minus in the middle because they're opposite signs. The first thing squared is x squared. The last thing squared is 100, and because it's a positive times a negative, there needs to be a minus in the middle. If you can jump straight to that answer, nice job. If you can't and you need to show your work, that's okay too. You'll just get x squared and then a minus 10x. And then a positive 10x, and then a minus 100. When you combine your like terms, you're going to get the same answer. And that's the last special multiplication one. So we have to square. You need to remember means to multiply something by itself. And if you have two items that are the exact same binomial, there's just a minus difference between them. One's positive, one's negative. You're going to get the first thing squared, the second thing squared with a minus in the middle. And the middle parts will cancel out because they're opposite in sign, but the same number. That's the end of multiplication. Now we're going to do the introduction to division. We're going to actually time travel first back to middle school. It turns out that you did something in middle school that is very helpful for what we're going to do in the last part of this lesson. In middle school, you learned something about what's called the greatest common factor of two numbers. That's the biggest number that divides any given two numbers. So what's the greatest common factor of 12 and 18? What's the biggest number that divides, that goes into 12 and 18? Well, some of you might know, just because you've worked with numbers so long, that it's 6. Well, before you could just do that off the top of your head in middle school, you had to make these factor trees, what we call the prime factorization of 12. 12 breaks down to be 4 times 3, and 4 is 2 times 2, so this is 2 times 2 times 3. 18 breaks down to be 2 times 9, and 9 is 3 times 3, so it's 2 times 3 times 3. And then you'll notice, what do they have in common? Because I'm looking for the greatest common factor. They both have a 2, and they both have a 3. And 2 times 3 just so happens to be 6. And that's how you find the greatest common factor when you don't know right off the top of your head. After you learned that that worked for numbers, hopefully you investigated it with variables. If I break x squared y down, I'm going to get it's x times y. If I break xy down, I get x times y. If I ask what's the greatest common factor of these two items, I'll note they both have an x and they both have a y. Can't do any more because this second one doesn't even have anything more. So the greatest common factor of these two would just be xy. Now what we're going to do is we're going to start to put those two concepts together. What if I ask what's the greatest common factor of 12x squared y and 18xy? Well, it would be logical if I just looked at the numbers first. So what's the biggest common factor of 12 and 18? It's 6. And the variable parts we learned a second ago is xy. So the greatest common factor of this number and variable expression is just going to be 6xy. It's the biggest amount of numbers I can divide out of both and the most amount of variables. I can divide a 12 and 18 by 6. This has 2 x's, this has 1, so I can divide an x out of both. This has 1 y and that has 1 y, so I can divide a y out of both. That greatest common factor idea is actually going to be very helpful because what we're going to do here in a moment is the very beginning of division. It is similar to what you do when we're doing distribution. It's just distribution is the forward process, the multiplication. So as an example, let's say I had something like 3x times the quantity 2x plus 5. And you know from practicing this before that your final answer for this would be 6x squared plus 15x. But here's the idea. Imagine that you didn't know the original problem and you needed to try to work backward to figure out what it would be. So how would you think through that? Well, you might say to yourself, okay, well, if this is a 6 and a 15, what would multiply and get me a 6 and a 15? Or what's the biggest number that I can divide into 6 and 15? And 3 is the biggest number that goes into both 6 and 15. And then I do it with the variables. This has this has two x's and this has one x. So if a variable is going to distribute into both, what's the most amount of x's that could distribute into both? Well, it had to have just been a 1x out front. If it was any more, this would have been bigger. This only has 1x. And then in parentheses, we'd have to think to ourselves, what must be in the parentheses so that I get this as my answer? Well, if this is a 3, then I'm missing a 2. This has two x's, so I'm missing an x. This is a 15, so I'm missing a plus 5. This only has one x, and I'm going to get that 1x, and so this must have been the original problem. And how do I check? Because when I distribute it back through, I'll realize, voila, I get the original problem. So what we're trying to think through here is, well, multiplication, distribution is the forward process. We're going to be doing the beginning of division. And in quadratics, we call that factoring. So we're going to be factoring out, which means to divide out. It's the opposite of multiplying. We're doing the distributive property in reverse. So let's give it a try. If I had 4x to the fourth plus 24x cubed, the first thing I would do is just look at the numbers. What's the biggest number I can divide into 24 and 4? Well, 4 is the biggest number that goes into both. What about the variables? This has 4x's. This has 3x's. What's the most I could divide out of both? Here's an analogy I like to use when teaching this. Imagine you're hanging out with a group of friends on the weekend, and one of your friends only has $5. Are you going to do something as a group that costs like $8? Probably not, because you're not going to want to leave them out. Similar thing goes on with the variables here. This only has 3x's, so I can only divide out at most 3x's. That must have been out front. Now in parentheses, I need to write what would be left behind, what would have to be in the parentheses to make this as my final statement. Well, 4 times 1, so this would be a 1, will make 4. This is 4x's, so there needs to be a single x left behind. Plus 24 divided by 4, I must need a 6 here to make 24. This already has 3x's, and I'm going to get them when I distribute it, so this would be my answer. 4x cubed times 1x plus 6. How would you know that you're right? Because if you distribute back through, you're going to get that as your final answer. You would see the book write it like this, though, just be aware. You're going to see the book write this as 4x cubed times x plus 6. They don't usually put the 1 in front of the variable. It would just be implied. So there's that one. Let's try one more before I have you try. Zoom in so we focus in on it. So same idea. Start with the numbers first. What's the biggest number I can divide out of 9 and negative 6? Well, it must be a 3. This has 7 x's, this has 5 x's. The most amount of x's I can divide out of both is 5, because that last one only has 5. Now I need to write what's in parentheses, what must be left behind when I divide out a 3 and an x to the 5th. Well, 3 times what would get me to 9? Well, I need a 3. This has 5 x's, I need 7, so I need 2 more in the first statement. 3 times negative 2 is going to get me to negative 6. I don't need any more x's here because all 5 are going to come and get it. So there's your final answer. 3x to the 5th times 3x squared minus 2. How do I know I'm right? Because if I distribute through, I'm going to get my original problem as my final answer. So it's the opposite of multiplying. We call it factoring, the beginning of division. I'm going to ask you to try. So you try with the following two on the right. Can you divide out the greatest common factor to simplify these two expressions? So maybe pause the video now for 2 minutes, unpause it once you've had a chance to try. Let's do this too. To make this just a little more approachable, let's put a 4 out in front of this one. I'll make it kind of more applicable. So put a 4 out in front of it and then give it a try. So pause the video now, come back after you've had a chance to try. Okay, let's give it a go. What's the biggest number that goes into 4 and 8? Well, 4. This has 6 d's, this has 2. What's the most amount I can divide out of both? Well, just 2. So 4d squared. In parentheses, what's left behind? There'd be a 1. This needs 6d, so I need 4 more. Plus, this has to be a 2 to make 8. I've already used both d squared, so I'm done. 4d squared times 1d4 plus 2. Last one. 5 and 15. The biggest number that goes into both is 5. This has 4 D's, this has 6 D's. The most I can divide out of both is 4. In parentheses, I write what's left behind, or there's a 1 again. I don't have any D's because all of them got divided out, plus 3. 5 times 3 is going to make the 15, and then I need 2 more to get to the 6. And there'd be my final answer. And that is it. Thank you very much, and have a good day.